All right, guys. Opener problem today. 2.5 times 5 2/3. Something that we did, but if you don't do it often, sometimes you forget. Who can tell me what was the first step that they used to start this problem? Yeah.
Turn it into a mixed number, or improper fraction.
Okay, so what improper fractions did you get when you did that?
The first number is 5 over 2.
Okay.
And then the second number is 17 over 3.
Okay. Ew, I don't love 17s. I don't see anything I can simplify there. Do you guys? Close, come up, or turn it around, or do something. So then what did you do? Because since we don't love 17s, yeah. Okay, so you multiplied your numerators and got what? 85. Multiplied denominators, got 6. Looking at this, it does not look like I could simplify it. But what could I do? Dylan?
No. Sorry, I forgot the word.
Okay.
Can you go to someone else?
Sure, absolutely, yeah.
You can't simplify it, but you have to do the remainder as a fraction.
Okay, so explain. What else might we call that? A mixed number. Hey guys, this is a perfectly good number. It is not bad. I know Savis hardly ever takes it. That's their problem, not ours. Okay. This is a perfectly good simplified number. But it doesn't tell me how much flour to put in my cookie recipe. I don't understand it. So what could it be, or what is it as a mixed number? Oh, so many choices. Oh, so 6 goes into 85 12 times? And what's that? Okay. Uh, 6 times 12, so I was double checking, is 72. So we might have, and that happens all the time. Yes, sir.
I got 14 and 1/6.
14 and 1/6. Okay. So if I have 14 times 6, that's 84. Oh, and I had 1/6 left over. Is that sometimes the problem where we make mistakes in the converting it back? Yeah. And I love somebody mentioned, well, you just divide it and use the remainder. Yeah. I wish my 8th graders could remember that. Okay. We don't use the word remainder. The word remainder is a terrible, terrible word. But we could make a mixed number all day long. And it has meaning, which is great. Okay? That's it. Now, I want to give you just a quick set of examples or notations for today's lesson. So yesterday's practice, we focused on right triangles, squares, rectangles. Everything had a nice right angle. The world doesn't work like that. Hopefully when you build something, your walls and your floors have right angles. There's actually ways to check for that. It's really important. But there's lots of other shapes in the world. And so when we get to other shapes, parallelograms and other triangles, how do we find the base and height? So you'll notice in your notes the typed ones that I did, which are kind of an addition to the videos. Okay, that I'm giving you the formula base times height. When you first learned rectangles, you learned length times width. Well, is it any different? No. And the nice thing about base times height is it transfers into other polygons, not just rectangles. That's why the more mature way to say it would be base times height. Do I care if you use length times width? No, I don't. Okay. In my head, I still do it lots of times. Okay, but what if you have a triangle that looks like this? The triangles that we drew when we were little kids. Okay, mostly isosceles-ish triangle. I'm not going to prove it because I don't draw them perfectly. The height cannot be a slant. The height has to be perpendicular. That is a big word and I don't want it to be on a spelling test. But what does it mean, perpendicular? They exactly cross at a right angle. Okay, right now I am standing. Sorry if you guys are online, you can't see the way I'm standing, but I'm kind of on one foot, leaning, tilted. Am I perpendicular? No, we do that all the time, right? Yes. If I had been in the military, would I have learned to stand much straighter? Shoulders down, feet planted, body straight. Just a smudge bend in the knees so you don't faint. And that's it. Okay, it's actually a very good way to stand, and it's very perpendicular. That's the difference. You're usually going to see the perpendicular marked with a dotted line. Okay, so I'm going to make this height 5. I don't know why I feel like 5. What would be the base of this triangle? This is actually a really important thing I want to show you guys. Okay, usually we think of it as the bottom, right? My brain thinks base is bottom. It's wherever the height and the outside line make the perpendicular connection. So if I had, say, a parallelogram, okay, and I made a height like that, what if I kicked it over? Is the bottom still the base? Okay, wherever this connection is, that's your base. So in case you see one that's kicked over nicely, I'm going to look for one in our book. Oh, here's a great one in our book. Where is it? See number 9 right here? The base is that. The height is that. See how they connect? So pay attention to that. That gets or confuses some people. Okay? Another kind of triangle you might get is an obtuse triangle. Weird looking ones, great for art. You're typically going to see the height of that one as a dotted line right here. There's your height. It's measured by extending it out. Okay. Now, we're just going to do this guy right here, A. Who wants to give it a base measurement? Yeah. 15, okay. We're going to say that Mrs. Atkinson does not draw to scale, because she does not. Okay, so if the height is 5 and the base is 15, what's my formula for triangles? Jacob? Okay, so I'm going to write down the formula. Area equals 1/2 times the base times the height. Every time you do a problem, you need to be writing down the formula. Every time. Then I'm going to put in the numbers. Area equals 1/2 times 15 times 5. Now, it's multiplication. You can multiply anything together in any order you want because of commutative property. I think I want to multiply 15 and 5 first, just to get it over with. Bless you. What is 15 times 5? Okay, what's your question?
15 times 5 is 75.
Okay.
But my question was, can you multiply 15 times 5 and then just split it in half because it's triangle now?
That's exactly what you're doing. Excellent. Okay. So now we have 1/2 times 75. Now, 1/2 times 75 is exactly what he said. It's splitting it in half. If I have $17, okay, and I'm going to give half to Dylan, I'm going to give half to Reno. How much are they going to get? Oh. We don't know the measurement, right? If it doesn't say centimeters, inches, whatever, you write units, because we don't know what the units are. So just call them units. Okay, that's the generic name. Okay, yeah. All right. Now, why is there a 1/2 in the triangle formula? Does anybody remember from videos or anything?
Because a triangle is 1/2 a square.
Okay, it's 1/2 of a square. Yeah.
Because when doing a triangle and multiplying it, you have to split it in half.
Okay. Does anybody remember from the video anything about sandwiches? Your teacher seemed obsessed with sandwiches. How come?
Because you wanted one.
It is a good example, okay? Okay, does anybody, did I say in the video what kind of sandwich I was talking about? Okay, yeah. My daughter was obsessed with grilled cheese when she was little. And when she was sad. Somebody broke up with her, grilled cheese. Right now, if it's just a bad day, grilled cheese. And grilled cheese was extra special if mom made it for whatever reason. I don't even eat grilled cheese, for the record. Okay, extra special if it got cut into triangles. So your bread comes in a rectangle-ish, square-ish shape, depending on which bread you buy. cut it in the triangle, and it just felt special. But that's something most of us have seen, right? We've seen a sandwich that somebody cut diagonally. That's exactly how a triangle works. Any other questions about these shapes, about using the formulas? Yeah.
You always do the 1/2 because like any kind of triangle.
Any kind of triangle, every kind of triangle always has a 1/2. Yeah. The other one we're going to get to next week is trapezoid. It has a half in it too. And I'll explain why, because it's a different reason. Okay. All right. It is your work time.